All right. So we were here. So we talked about the h minus k. We talked about this value here. So this means that it's going to be x plus 3. So when I use my equation, y equals a times b to the x minus h plus k, I found my k value to be -4. Am I writing now? So sorry, guys. All right, so make sure, because I'm writing on this, I might get in your way. Tell me to move if I'm in your way. All right. What did I do next? I'm sorry, I forgot. Oh, yeah, I found those points, didn't I? So this is the point 3, -3. And this is the point 4, -2. Agree? And then we said, let's use this point because it makes it nice, because when I'm plugging the wait a minute. Dude, did I oh my gosh, jeez. I was right on the first one, and then I'm so wrong here. Sorry. There we go. All right, so then when I take this x and y value and plug it in, I'm going to get -3 is equal to a times b. 3 minus 3 minus 4. -3 equals ab to the 0 minus 4. And we said b to the 0 is 1. So a times 1 is a. So that gives me a is equal to, if I add 4, a is 1. And then this is where I was mysteriously talking to myself, and I was writing to myself, and no one else could see because I was using the invisible ink, right? Okay, so let's use this xy value and plug in everything we know, including we have our a term, we know this term, we know this term. So I'm going to get y equals a, which is 1, times b, we don't know yet. And then I have x minus 3, and then I have -4. And if we take that xy value, plug it in, I get -1 equals 1 times b, 4 minus 3 minus 4. -2 equals, I know my head's, so we get that. We agree with that math so far. I had a nice trip. I'll see y'all next fall. Woo! Sorry, I knew it was a bad day to stop sniffing glue. I knew I should have before this class done. I'm just kidding. I still sniff glue. All right, so then I get b is equal to 2. Now I've established everything I need about this problem. So I have this, and I have this, and then I know this has to stay there, and I know that has to stay there, right? And we're going to leave x and y alone. So I get y equals a, 1, b is 2, to the x minus 3 minus 4. Friends, do I really need to have the 1 out in front? No. Liam, I'm going to make this easier for you. All right. Now let's see if I can fall on my face and knock a tooth out on the next problem. Sound like a deal? Tooth fairy will come and be awesome. Just make sure you have your cameras out, film it. We can make money. Can I move on? Okay. So next problem. It flips upside down. So we know we have a negative. Now the problem is, do I have a negative a value, or is the x negative? And we can't always remember it. And that's okay. We can figure out everything we have here. So I have y equals a times b to the x minus h plus k. Okay, my k value should be pretty easy. 0, okay. So that'll be a 0. my h value. Let's look here. It appears it shifted which direction? Left. So that means that's going to be x plus 3 with a base of b. We have plus 0. We have an a that we don't know, and we have this. So I got all of this just by kind of looking at the asymptote and the shift. And again, the shift, look for the value that is closest to the y-axis, and that'll tell you what your h value shift's going to be. Cool? Everyone all right? Okay. So now I know that this is the point -3, 0, -1. And I know this point here is -4, -3. Okay. I'm going to pick the one that's going to allow me to get my b value to become 0. That whole exponent becomes 0. So if I plug this one in, I'm going to get -1 equals a times b, -3 plus 3 plus 0. Do I technically need the 0 there? No. So let's just clean it up to say we have this. B to the 0 is 1. So a times 1 is just a. So my a value is -1. Hey, that tells me right now, where my negative is going to fall in this problem, how it flipped over. Agree? So now I know that I have this value here. I don't need the plus 0. I'm okay with that. I want to make sure I plug this in as well. So I'm going to get y equals -1 times b, x plus 3. Again, I'm ignoring the 0. If that was another number, we'd keep it. Now I'm going to plug this x and y value in. So I get -3 equals -1 times b, and I get -4 plus 3. -4 plus 3 is -1 this week, right? So I'm going to get -3 equals -1 times, oh, wait a minute. That's b to the -1, which is the same thing as 1 over b. So I'm going to do this. Does everyone feel comfortable why I just did that? Does that make sense? So then we have a little bit more to this. So that means that I get, multiply this, I get -3b equals -1. Divide each side by 3. Negative over negative is positive. I have my a and I have my b values, so let's plug those in. -1 times 1/3 raised to the x plus 3. We can put the 0 in at the end. It's not wrong if you don't have it there, but that's our answer. So we use the points twice, but we have to logically think about which points would allow me to get that b value raised to the 0 power. If we don't do that, then we're going to have like a radical in there, which is okay. But they should have worked. It should have worked both ways if we didn't do that. Good? And I don't know what time we get out of here. Anyone else? It's like, yeah, we've been out for 10 minutes, pal. Thank you. All right. I got about 12 minutes to finish up. We good? Can I move on? All right. What powers of 2 do we know quickly? 2 to the 0, 1, 2 to the first, 2 to the second, 4, 2 to the third, 8, 2 to the fourth, 16, 2 to the fifth, 32, 2 to the sixth, 64, 2 to the seventh, 128, 2 to the eighth, 256. And that's as far as I'm going to go with that. Do you agree with that? Like 2 to the eighth is 2, 2, 2, 2, 2, 2, 2, 2, all multiplied together. So then we have to think about what are we going to have to do to write the equivalent form. So look at the right side. I have 2, and then it's raised to like a circle. What do I have to do to that 2 to make it become a denominator? Yeah. Yeah, so this becomes a negative 1. 2 raised to the negative 1 is equal to 1/2. Notice it's not negative, and I know you all know that, but it's kind of a simple mistake. Then we get to this next one. So I got to figure out what that is. I know it's going to be negative. All right. If I make it a negative, that means that 2 is now 1 over 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this value has to be 2 to the negative 5th. 2 to the negative 5th is 1 over 32, because 2 to the negative 5th becomes 1 over 2 to the 5th. 2 to the 5th multiplied 2 times itself 5 times, we get 32. This one, I have to flip the fraction over. It's still going to be negative. So 2, or 1/2 to the what power? 6. So it's a negative 6. So 2 to the 6th power is 64. Now some people will say, hey, do I have to have those memorized? No, it's pretty easy to go 2, 4, 8, 16, 32, 64. Okay, you have a calculator you punch it into. You're fine with that. Just keep times in 2. Can I move on? All right. Now we change to 3. So we have to think. 3, 9, 27, 81, 243. So 3 to what power gives me 81? Negative 4. Good. It's negative because it's the 1/3. The 1/3 to the negative 4 means it's going to be 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which indeed gives me 81. This one has a trick. This is mean and nasty. See that negative right there? If that negative wasn't there, I will tell you it's 5 to the negative 2 all day long. But I can't multiply 5. I can't raise 5 to an exponent, positive or negative exponent, that will ever give me a negative base. No solution. No solution. Make it better than that. Make it this. No solution. It's no solution because that negative right there. I can't raise 5 to an exponent. I can raise 5 to an exponent and make it a fraction by making it a negative exponent. I cannot raise 5 to an exponent to make a negative base of a number. Okay? This one works though. 1/3 is 81 to what power? I know it's negative. What times what times what times what gives me 81? 3, 9, 27, 81. So 81 to the negative 4 is the same thing as 1/3. Wait. Whoa, dude. Who just came in that door over there? Who's there? There was nothing there. I see what I just did. Oh, yeah. All right, 1/3. 81, let's change 81 to 3 to the 4th power. Because 3 times 3 times 3 times 3 is 81. I'm sorry, I don't know what I was thinking. That trip must have been a little bit better for me than we would have thought. All right, so what do you think? How much? So 3 to the 4th is 81. Can I make 81 1/3? What do you think? This is a tougher one to think about because this is definitely not the right answer. So we have to think about it. Yeah. Negative 1/4 power. Okay, negative 1/4. Yes, it is. Why does that work? You're absolutely right. It fourth roots it. Fourth roots it, and it makes it a fraction. So let's just kind of hold this one on a burner. That's a tougher one. That's like, varsity level pre-calc question. but I like that. All right. Hey, can I multiply a number times itself a few times to still get a negative number? So 2 squared would be positive 4. Negative 2 to the third would be negative 8. So I have 2. So as long as 2 is going to be raised to an odd number. So let's see. I have 2, 4, 8, 16, 32, 64, 128. 7 is a odd number. So negative 2 as a quantity to the 7th power gives me negative 128. That's negative 2 times itself 7 times. How much more do I got? 2 pages? Oh, sheesh. Okay. Okay. And I'm not going to force the issue. If we don't get done, we don't get done. And all right, first thing I want to take care of. I want to take care of that negative right there. So this is going to be negative 5 over 3. Oops. You know, I'll tell you. 3 over 5 to the third. Do you agree? So negative times negative times negative is negative. Agree? 3 times 3 times 3 is 27. 5 times 5 is 25. 25 times 5 is 125. So that's the answer. Something to the 5th power gives me 32. Let's see. 2, 4, 8, 16, 32. 1/2 times 1/2 times 1/2 times 1/2 times, I think one more 1/2 gives me 1 over 32. What does this negative do? Flips the fraction, so I think it's 6 over 5 squared. 6 squared is 36. 5 squared is 25. Done. And then last one. Thoughts? This one can't be done at this point. When we get to logs and natural logs, it will be done, but at this point, you can't do it. All right, how much more did I have? 2 more? Do me a favor, bring these back next time, and will you decide that? Okay, bring this back next time. The nice thing is, Stirrup's computers don't work. Stirrup has nice trips, and he's going to see us next time he falls. And will you start 9F? So I'll leave time for some questions, and then I'll finish it up the lesson next time. Deal? The beautiful thing now that we're all back together and you're my only class is now I don't have to worry about dealing with the other cohort kids because you're all together. This is the best day ever for me. Any questions, friends? What time are we out of here? 1:03? Okay, I probably could have ran forward and you guys would have been mad at me. And then 4 parents would have emailed. But hey, it would have been fun. All right.